It's a great pleasure for me to present you the work we have done in the last 2.5 years. We have set up this Transkribus platform, and for me, actually, that's, if I can say maybe some quick words about myself. I'm now working for 25 years in the digital domain. So I'm a literary historian from profession. I wrote my thesis, rather conventional, 1996, and but then switched to the digital environment and was responsible for many years for large digitization projects, but also here at the university library, but also in cooperation with many other libraries all around Europe. One of the large projects was ebooks on demand. Some of you may know it. It's a network which is nowadays hosted by the University Library here in Innsbruck, and I think it has about 50 members now, and they are digitizing on demand books which are requested by users. In parallel, I always was interested in the technical development of text recognition, and actually I trained the first text recognition engine in 1992. So exactly 25 years ago, I recognized letters which were printed, of course, and from that time onwards, I was fascinated by the idea that it should be possible to have all documents, or at least all historical documents, available in digital format, plus searchable. And part of this personal vision, we started several projects, among them the metadata engine project. One big result was the first engine from Abbey for Gothic fonts, but also the establishment or the design of the Alto format, which you all know. And another big project was, of course, Impact, where I was responsible for the text recognition part. But the funny thing is that Impact did not really succeed in creating a breakthrough in text recognition. So when we started the project in 2008 and we prepared it in 2007, no one really had an idea that the revolution was just in front of us. There were some ideas, but all conventional. But in the late 2008, 9, and so on, important papers were written, and these papers and these software really changed the scene. And if you are now talking about text recognition, you are talking about a complete other level. So yeah, my feeling is that we are now really part of a larger revolution. Artificial intelligence is, of course, the main buzzword in that direction. So we are benefiting very much of that, and a lot of the progress we were able to make comes from this field, and so we owe a lot these recent technical developments. So I invited you to send us some image files, and I hope I didn't miss anyone, but I got some images from the British Library, and I got some images from, I think, Utrecht. And I thought before I start my presentation, I give you the background to the technology and some of the results. We simply have a look to the documents you sent us, and I can already tell you something what are the main things to understand for the background, for the technological background of Transkribus. So I uploaded images, Arabic, or images of Arabic documents. I think they are coming from this Endangered Archives program from the British Library. And the first step actually, which will not surprise you, of course, is to segment the images into lines and regions. And this is actually one of the big results we had in the first 2 years of our project, that several colleagues were working on that, because actually already 2 years ago when we started the READ project, and Transkribus is the research platform which is one of the main deliverables in READ, but READ has of course many other research deliverables. And the experts told me that one of the main challenges is not so much the actual text recognition, because here something happened, but more on the background, not so much really new, but to segment pages into lines and into regions. That's something where all groups were actually working. So we had several groups from Valencia, from Rostock, from Vienna, and from Athens working in this direction, and also creating a research competition. So the ICTA conference 2017, this year in Kyoto, had, I think, 2 competitions on line detection. And actually, the colleague from Rostock won for the middle age documents, and also provided the best results for the general documents. So, and this is really a major step forward. So let's have a look how it behaves on these documents. So I simply start here. The tool, it's called SITLab Advanced, but as you can see, there are other tools included as well. So this was the old tool. We can run this one. It starts a job. So everything is performed on our servers here in Innsbruck, and every user sees the jobs he has done. So the job is finished. And as you can see, this was the result until some weeks ago. It did rather well for that kind of document, which is not very complicated, but it had some problems. You can see here that probably because of some overlapping and so on and so on. Some lines were missed. Also, some arbitrary regions were created. So the result was okay, but not what you really would like to have. And if you look to the new tool, you can see quickly the progress. I think I made a mistake because I have selected one region, and then it takes the region. No. Okay. And you can see it's nearly without any mistakes. Now, to understand the concept of text recognition, the modern concept means that you are working, first of all, not with the line region. So the line region, as you may know, is defined by having a region which includes all characters. And I mean, for this type of writing, which is very neat, you have nearly no ascenders and descenders. It's rather easy, but you can imagine a lot of handwriting where you have a strong overlapping, and then like here, and then you always have the problem how to work with that. So one of the major decisions we made 3 years ago was that we do not go in the first step for the whole region, but that one line is sufficient to actually describe the whole polygon. So the line region would be a polygon, of course, but one line is sufficient, and you can see here this red line here highlighted. This line is the output of the segmentation, and starting from that line, the HDR engine or the engines in the background, the text recognition engine backgrounds, will compute the whole line region on their own. You need not to care about it. And of course, that's for users much easier to work just with this baseline than with the whole line region. So yeah, let's have another look how it behaved on other pages. As you can see here, it found all this very well, but it missed here something. Similar result here, and you can see here that this was probably not recognized as being part of a text line. And that's the second important difference to the all other algorithms so far. This baseline, or the algorithms we used so far, this baseline detection is based on, again, on learning algorithms. So the input were correct baselines, like this one, and the engine learned itself that because there is this baseline, it must be some text around. But what is actually the case is that when learning these, that this is text, we used about I think more than 1,500 pages, so something like let's say 40 lines per page, so probably 60,000 lines. So it's a good training set, and the set came from several different documents from the Middle Ages, from modern times, but it did not include Arabic documents. So I guess that mistakes like this are coming, or that it missed these lines, are coming because it was not trained on Arabic documents, and that it did not have enough examples that this is also text. In the current implementation, it is not possible to train the engine, the segmentation engine, but sometimes during next year, probably in Q2 or so, you will also have the chance to train, which means that in that case you would correct here this baseline, you would add a baseline, and that's it. And based on this input, probably the colleague told me that 50 pages are probably enough to enhance the model. So let's say 50 to 100 pages, and it would learn that this is also text, and results would be definitely better. Yeah, let's go on. No, we don't need this. Yeah, very nice page. And you will see that it missed here also a lot of text, and here it had problems to separate. Also, if someone can't read Arabic, you will see that that I also have a difficulty. I can imagine that this is maybe extra text, but I cannot be sure just from looking at the layout of the document. But that these mistakes, like that here we have vertical text, that's already solved. You just simply need to believe me that we have a parameter for arbitrary text direction, and here we have in the user interface just the parameter set for horizontal text lines, because that's 80% of the cases or 90% of the cases horizontal lines, and then it works, of course, a bit better if you have this parameter set. But that's something which will come in the next weeks, that you have the chance to say, okay, that's arbitrary. Like postcards, we trained it actually on postcards, and then it will work with this much better. It will not work perfectly as always, but it will work definitely much better. Yeah, let's have another look. So here you can see that it worked very well. Here it recognized this as text. I don't know, maybe it is text, maybe not. It did not recognize this as a text, or just a little bit here. And this is also due to the input of the training images. We had a lot of images from the Middle Ages which were scanned in a similar way, like this. You have the main page in the center, and the parts of the neighboring page, and and then it learned to structure also the complete page and to ignore that kind of text. Yeah, here similar situation. Here we miss a little bit, and we have here something, but yeah, that's perfect. Again, yeah. Then you can see that here it also already recognized nicely the column, but I have to say it was not trained on 4 columns documents. So I'm sure if we would have trained it on documents with more columns, it would also recognize that that this is a column. E.g. newspapers look similar, so it could be expected that it could learn this as well. It had problems with things which probably look more like noise or other things. Yeah, similar situation. Here it missed more. Again, the same situation. It didn't see this in the training data very nicely. Looks like a usual page. Again, and now it didn't work. So what you can see here is that it says a resolution of 72. The resolution is really bad. If you zoom in, yeah, it's probably it was expected to get um, another kind of pixel grouping. So for that kind of image, it didn't work, but would have worked very badly. So again, it would be necessary to add such pages for training, and then I'm rather sure that it would work. Same situation. So these images didn't work. That's worked partly. It's not an easy thing again. And then it worked again very nicely. Then let's have a look to to the other documents we got from, I think it was Utrecht. So here we got a typical official, I don't know, letter or protocol or whatever, and that worked perfectly. Then I was very happy to see that it worked also nicely on that kind of fragment. Also this fragment and fun. I mean, these were exactly the documents which it saw before. And you can see that even these additions were recognized as text, which is really which wasn't possible before. It didn't work on this because this didn't look like a document, not enough lines. And also in that case, it failed more or less. So it produced something, but didn't work very nicely. So this was the segmentation. But then we did a funny experiment. This document is actually, I guess it's Dutch writing. I can read some words, but not really. So let's change the profile. And what you see now is that the line segmentation, that this was, you still see the baseline. And from this baseline, now the line segmentation was done. So this means that that I run actually a model which we trained on documents from I think the 19th century, Dutch documents we got, a rather a big collection. I will show you later on, or maybe I show it right now. Let's have a look to these documents. So here are the models, the trained models for HDR or for, I have to say HDR is the wrong expression because it works, of course, also with printed documents and not only handwritten documents. So it's the same technology behind. It loads a bit because we already trained such a lot of models, and I'm an administrator, and therefore I see all the models. So this was walk. And I think I worked with that model or with that, but there's not a big difference. So what you can see here now is actually the learning curve of the neural networks. So in all cases, when we train a model, in all cases we have a train set and a test set. Train set means that we have pages with the correct baselines and the correct text. And test set means that, and based on the train set, of course, the neural networks learn to adapt themselves to the task, in that case, to read Dutch documents. And the test set is for having pages which are not part of the training and give us a bit an objective idea of what happens within the training, and the two curves shouldn't be too far away. Otherwise, you have either kind of overfitting, so that you have very good results on the test data, but bad results or not so good results on the training data. You have good results overfitting, and not so good results on the test set. So in that case, it's fine. You can see that on the train set we have 22% character error rate, and here we have on the test set 17% character error rate. And here are some technical details which are not very important. The learning rate and the number of epochs. So we have here 200 iterations, and it starts with knowing nothing about this writing, and then it goes down and down, and yeah, still improves a little bit, but not that much. And we can also have a look to the documents, how they looked like, which we had for the test. And they looked like this. So rather different from actually what we saw before. Oh, this is, I think, from the background. Here. So also with a lot of noise, but I thought somehow similar to what we saw in this document here. And so I run it, and the results are, as we can see, very bad. So I think it found here something, but here maybe the apotheker is rather near, but it's not really usable. But, and that's the big difference. I will explain it further later on where it comes from. But we also implemented, and that's really fresh, and it's currently not available to all users, just to some selected users, but will become available probably at the beginning of next year. This is called keyword spotting. And keyword spotting is apart from the fact that nowadays we use this kind of artificial intelligence and learning machines or machine learning for text recognition. The keyword spotting is also the direct answer on the output of these neural networks, because what they are outputting is not so much the text. This is just one option. What they are outputting is a kind of estimation how likely it is that a specific character appears on a specific spot on the page. And that can be utilized for searching, for a new kind of searching. And we can try it out. So if we look for Apotheker or for Temperatur, these were words I was able to read. And then we start this. This keyword spotting, since it is done directly on the so-called confidence matrices, so on the confidences, on the files themselves, it takes much longer than searching. There are, so it takes just about 3 seconds for just some pages, so that's of course rather long. But it is done in our case as a job again. And as you can see, we store all the results and the history, because we believe that the historian will afterwards work with that. But I will say more about that maybe later on. But let's have first of all a look to the results. And what you can see here now is that we get the confidence. So a confidence value between null and 1. 1 is that the engine is totally sure, null is that it has no idea. And 37 in our case means that it is rather sure that it found the word in the image. And indeed, I mean, also the transcription was rather nice in that case, just one mistake, but it found it actually. And with the temperature, you see already the power of this searching, because Leibniz is rather far away from temperature. So even with fuzzy search or something that alike, you never would be able to find this word, but with keyword spotting you find it. And that's really I would say, another breakthrough, which will revolutionize the work of scholars, humanities scholars, because as you can see, we already have models available which we can apply to that kind of writing, and we are of course gathering as many data as possible to improve these general models, which allow you then to search for the documents. Actually, we did the same for the Arabic documents, but I'm not able to read Arabic, and we discovered that the keyword spotting, um, that the keyword spotting that the keyword spotting still has problems with right to left writing. So everything works fine. We can train Arabic, we can train Hebrew and other writings, but we discovered that the keyword spotting also needs to work nicely with these Unicode characters, which have the writing direction included. So I cannot see if this really is useful output. But I guess if it looks like that, it's usually that searching works, but I cannot verify it. And this was done actually on Arabic newspapers from Israel, applied to handwriting here. And yeah, would be nice to maybe have sometimes then a look later on. Okay, so this was somehow the core what we are doing, and maybe I give you a little bit of background information now in the form of a presentation. Yeah, so everything is financed by the READ project. We have several research partners on board, but also already about 50 memorandum of understandings with different institutions, such as the British Library, where we are very happy. And we are looking for a kind of uh, governance model and business model, how to transform this platform into a sustainable organization. We are currently investigating the idea of a cooperative because we believe that it would fit rather well to our core mission. And our core mission is that we want to provide services for archives, libraries, humanities scholars, computer scientists, and the general public. And I think the more institutions would take part, the higher the benefit for all. That's one of the main messages. And as you could see, it's already there. It's still a bit hidden. We have to work on that, of course, that we make all the data which are already there and the different models better available to everyone. But the direction is totally clear for us, and yeah. For the business model, because of course governance model is one thing, the business model another thing, we are thinking on a kind of freemium model where all users can work with all services for free up to a certain amount of images, and then probably some subscription levels such as basic, standard, premium, something what you already know from other models. And that would include the processing of some tens of thousands of pages. And of course, what I can say is that if it comes to large amounts of documents, we are prepared for that as well. All the services are already available via an API and can be used to process large amounts. So the interface what you have seen before is mainly to produce the ground truth data, to also measure, which is very important, to measure the results of the recognition, and then to train models, to apply models, to have a look. But then when it comes to large, and that's already a lot for many research projects which are dealing maybe just with thousands of pages or some 10,000s of pages, that can easily be done also via the graphical user interface. But if it comes to large amounts, then of course the API would be the main choice. Yeah, that's the graph for what I told you before. And that's again, what I already said. Yeah, text recognition, segmentation is just one part of the other work. Other groups are also working on some other parts, but I think I can switch that. The REST API in the center, the expert client is one way to access this. We have other web interface currently. We are working on an e-learning interface, command line clients, and so on. The Transkribus server is actually hosted at our central university, central computing center, the central computing facility at our university. And so we have a good infrastructure available and also a lot of storage. And in the next few months, we will include also GPU servers to speed up the recognition. Then the MOU partners. Yeah, I already said this. We have an automatic text recognition. It's not necessary to select or to structure images and text into single characters, but it is working with the whole line. And in between the image and the complete line, there is this neural network which finds itself the correct rules to create the correct output. This is very important and very interesting because it shows you directly what is the influence of training data on the character error rate. So CER is the character error rate. And here you see the number of lines. So a first model was trained, the blue one, with 428 lines. And it showed a result of 22% character error rate. And then the colleague Gundram Leifert from University of Rostock, he doubled always the number of lines, 857 and so on and so on. And you can see that it improved for several percent, and the more data you add, the more it improves. So you can imagine that with more data it goes down and down. And actually, the people working on these training data, they are sitting at the University of Greifswald, and they have now one of the largest models, I think more than 2,000 pages actually transcribed. And they report that they already come down to below 5%. Some pages are around 3%. So they have really a lot of training data. What you also see in this chart is an interesting experiment. So Gundram introduced noise actually to the images. So here you see on the left-hand side no noise, and here you see different kind of noise. What means noise? In contrast to the traditional way of OCRing, where you try to enhance the image, here you put noise to the images to make the neural networks more robust. And so you feed them with somehow destroyed images. You take the little line region and you put salt and pepper to it and other things, and then you can see the effect. It learns faster. So it's more challenging for the neural networks. It learns faster. At the end, when you come down, it will not make a big difference. But to have results earlier on with not so many training data, it will help. Yeah, then some results from real-world projects. So this is Latin text actually very nicely. And what we discovered here is that it also learned the abbreviations. So you can see here Remus, and you see here a specific letter for us, and it learned that it should expand automatically this into us. But it learned even to expand Nostra, as you can see here, an N and an R with a special sign. and it learned Nostra. Again here, Premissimus, it learned again that this is a pre and this is an us, learned that this is an etc., and so on and so on. It's really fascinating that the input, of course, were expanded text, was expanded text, and without any specific characters for the abbreviations, and it outputs expanded text. Yeah, I already told you that it is also able to learn Hebrew or Arabic. This is typical German handwriting, current, and got now really good results. So at that time it wasn't that good, but nowadays it's even better. Then Italian archive. This is interesting because that's really carbon copy from the 19th century, and yeah, worked also rather well, as you can see, something like 13%. Then German handwriting from the Second World War, also, and the multi-writer protocol from Switzerland. So in that case, we mixed, I think, 20 to 30 writers from a period of half a century. And of course, you have the average is not is an average, and you have, of course, significant changes on single pages. So it depends a lot on how similar a given writer or a given hand is to the training data. So you can see here it's rather challenging writing and very different writing, as you can see here. And because I guess some of you are dealing with more with printed documents than with handwritten documents, I can report you from a project we are doing with the Austrian National Library, or not directly with the Austrian National Library, we do it with the Austrian Academy, but with newspapers from the Austrian National Library. And here we have now a research project where people want to have about 4,000 pages very completely corrected. They do this in Transkribus with a service provider at hand. And after some issues, we train the model, or several models actually, and the results are very, very good. So 1 to 2% character error rate on average pages. If they are really hard pages, then it is, of course, not that good. But in comparison to fine readers, so fine reader has about 10% character error rate on average pages, and so it's yeah, at least a factor of 5. It's better than the usual standard OCR. That's the learning curve, and that's the kind of writing, as you can see. Yeah, typical 18th century Gothic letter. So what can you do with that? Actually, as a rule of thumb, when you want to transcribe, then the results need to be good. Because even, especially if you are an experienced writer. So you can measure if you have a page with 15 to 20% character error rate, it's not really usable for correction. It makes no sense to correct because it's exhausting. It's of course good enough for searching, as I've shown you before. Keyword spotting will work very nicely with that kind of character error rate, but not for enhancing transcription. Between 10 and 15% users are equal or faster. Some, especially experienced users, will prefer the key because keying is somehow more convenient to human beings than spotting errors. But especially users which are not so experienced, they will definitely already get some hints and benefit from this. And if you go then down below 10% or even below 5%, then even experienced users will definitely benefit and even enjoy it to correct. Yeah, I already showed you how the correction of training data works. It's just doing the segmentation and doing a keying of the documents. But that's actually just necessary for uh, documents where you don't have already transcriptions. If you have transcriptions, we can use it also we can use a tool, or a tool is included in Transkribus, which generates an automated matching of the data. And that's rather interesting. So the prerequisites are rather easy. We just need the transcriptions as text files on page level. So we do not need line breaks in the text file. So if you have e.g. a TEI file, which is the usual case, scholars are working a lot with TEI, text encoding initiative, and they have a document, and maybe it's not the line break is not encoded. That makes no difference. So how does it work? This image shows it rather well. We have here the text, and what it needs is a kind of already trained model, which can be very bad and can come from a completely different or nearly different writing, but from a different hand. And then it tries to match the existing text with with the um, with the um, with the um, um, with the image. And as you can see here, we have here confidence rates again. So it says that this line was matched with a confidence of 55 to this line. But here the confidence value was below the threshold, and therefore, in order to avoid any kind of mistakes, it did not match. But of course, we can also think to set the threshold and very low, then it would probably match it. But that makes sense if human beings have a look at it and correct or validate it. But in that case, that wouldn't be necessary. So for the complete automated process, it just takes the, the, the lines above the threshold. So in that way, we can produce training data much easier, because if there are already transcribed pages, then we gather them and produce a first model. And now some words, final words to what makes the difference between text, automated transcription, and confidence matrices. So what is the output? The output, what you usually expect, is kind of alto file. So you get the text, we call it transcription, and that can be measured with character error rate and word error rate. But what is new is that you also get so-called character lattices or confidence matrices. And that's actually the much more valuable output, because it's also the output which produces this automated transcription. So there is one more step compared to what you are used from OCR engines. What is the automated transcription or the text generation? It is that, as I said, for each letter in the alphabet, we have a probability value for each section in the image, and the text output is then the best path through. So you have to imagine here, cat, this blue line is the image. So that's, let's assume, is the text line. And this character here, or this image, is part of the image. Actually, the engine doesn't know that it is a character. It just knows this is a group of pixels which are interesting. And this group of pixel gets for this group of pixel, for each character in the alphabet, the confidence value is set. So that this is an A is maybe 0.4, here that is a B is 2, that is a C is 6, and so on and so on. And if you have a look, what is my best confidence? I get cat. So the best pass through this table is cat, and that's the transcription. And of course, the best pass through can also take into account dictionaries. So that's called decoding. So here we have the confidence values, and we decode them into text, and we can use several methods for that. The easiest way is just to have a look what is the best path through. That's what we are doing. That's what you do if you run Transkribus and you don't select a dictionary. If you select a dictionary, then the decoding takes also into account the words and might overrule somehow this confidence matrix. But as I said, this is just if you have a good situation, then cat is the correct solution. But what if we do if the best path through is not does not deliver the correct word? And that's exactly that keyword spotting can deal with this problem, because it does not search directly in the text. So it's not a text search. It's a search in the confidence matrices. So and these confidence matrices describe the images in a different way than the actual transcription output. So let's assume that cat was not the best passed, but eat. So you can see here the E looks rather similar to the C, and therefore the engine believes this has a higher value than the C. And so the best pass through would then be eat, but not cat, which is written in the image. And so we would have maybe a long list of alternatives which are higher ranked than our correct word. So that can be not only 7, that can be many words or pseudo words which have a higher confidence than the actual cat. But as you have seen already at the beginning, when we search for cat, we will find it at that place as well, because it has still a good confidence value. And that's more or less how keyword spotting is working. So I show you here an example from a very bad recognition. We are looking for the word Mitterlehner, and this and the automated output was Moifes Heckner, so really far away. But when searching, you see with a confidence value of 20, you still get the image, and you have also higher values as you have seen before. Yeah, that's really what makes the difference, and of course it changes a lot, because there is no real text available for further working. So many operations like named entities recognition and so on, which are used to be performed on actual transcribed text, will not work anymore. But on the other hand, you will be able to deal with handwritten text in a new way. So of course we are thinking to offer in the interface the chance to validate the results. And so here the first 5 results would be correct. So you would say that's correct. And here these 2 results are obviously incorrect. So you would mark them as incorrect. And then also be able to output them, e.g. as Excel file, but also e.g. to build up a new post search index, which can be used then also by other users. Yeah, so that's what I already said. But when we are searching, one last thing, and then I close. When we are searching, it's very, very important, especially for historians, for scholars, to know what did I miss. And and that's also something which comes from keyword spotting, that the historian or that the user who is searching can decide by his own how deep actually he will go. As you know, precision means how many hits are actually correct, and recall means how many hits did I get and how many hits should I get. So, and you probably know this, the precision recall curve. It shows us um, exactly what we can expect from a certain document. And this precision recall curve will also become part of the Transkribus interface. The character error rate thing is already, so you can already measure character error rates in Transkribus. But this precision recall curve will also work. Of course, it will also require that at least one page is there correctly transcribed, and then you can compare. So what does it mean? If we take this spot here in the precision recall curve, we can say, okay, these are the incorrect hits, and here we have the correct hits. So this means that 9 out of 10 hits are actually correct. So when you get a list of hits, 9 of the results in the hit list are correct. So it's really great. You need not to have you can more or less say, okay, all my hits are valid and fine for me. But you have to be aware that you missed these relevant hits. So if you have here now a look to the recall axis, then you see that we are here a bit beyond 0.8, and this means more or less that 2 out of 10 which were actually in the documents, so potential hits were not found. Yeah, which might be already too much for a historian who really wants to know that this person name appears in this document set that often. So, but if you go down to a lower rate, you will lose, of course, precision. So in that case, now you have 5 out of 10 results in the hit list are correct, but 5 are incorrect. So you have to have a look to many incorrect hits. But now you can be sure that you missed only 2 out of 100 hits, which will never appear in your result list, but are actually in the document. And that's probably a rate where a historian will say, okay, I can live with it. And that's something I can write down in my paper, and that's still my message is still my conclusions are still valid based on that results. Yeah, so I believe that really makes also a difference. Okay, yeah, use cases. I already mentioned this. Of course, historical research will change very much based on the ability that historians themselves can train models, can upload documents, can work with Transkribus. We have a very nice example here in Innsbruck, someone working on silviculture and interested in specific things. And finally, I just to have it mentioned, I would like to show you, oops, what happened now? Yeah. Something we also invented during the project. This is a kind of scan tent. As you can see here, you can place a document inside, and the orientation is wrong in that case. But what the most important, and that it has some light, and I mean that's an early prototype. We have improved it very much, so that's far away from what is now the reality. But what is more important is that you have here the mobile phone on top, and with a specific app which is already usable and can be used. And when you turn the page, then the picture is taken automatically. And this means that you have both hands free to turn the pages of a document or to place a document inside, and it takes automatically the picture. And also it can be uploaded automatically. That's part of this app, to upload it to the Transkribus app. And maybe that's where I stop my presentation to give you a quick look. So it creates a picture, it creates something, and then so you would see a kind of document, or the document which is produced, and yeah, that's coming directly from the camera. My colleague, she worked with documents from the 17th century, and you can, maybe let's have a quick look to them as well. So these pages are also taken now with the scan tent and directly uploaded. And as you can see, it's coming from a mobile phone, but has excellent quality because of the light, because of the stable situation. And of course, we also did here tests with keyword spotting, and it worked here as well. No, not on that document, sorry, again. But it's already working. Yeah, so this was more or less my presentation. I'm happy to answer your questions, and I'm also happy to do more tests with your documents, or if you want to support us, then we are very happy to join to conclude a memorandum of understanding with you. And maybe I should have said that we have now already more than 8,000 users in the platform. Of course, not all of them are working simultaneously, but we really have a number of groups working, doing their daily work with Transkribus. So it's really productive, and we are happy really to see your documents and to cooperate with you. Thank you. So as you can see here, these are files from an archive here in Tyrol. And these are reports for the mining industry in the 16th century. So, and the colleague is working on the silviculture. So wood transportation was an important thing. So she is interested just in some specific keywords and names and so on. And so she was working 2 weeks taking the pictures. This is of course just a small part of them. Taking the pictures and now uploading them, and yeah, and then try to write the paper on that. So, and then I think keyword spotting really is interesting for her. So maybe what is also interesting for you is how much work is actually to become familiar with. I think that researchers who have worked a bit with OCR and so on, and who have who are not shy with technical things, I mean, they can learn it within several hours. And that's actually one of the objectives that we will come up with regular webinars and with regular hands-on workshops, hands-on and videos, so that people, of course, if you start the program the first time, then oops, there are a lot of buttons and how do I do what, and then maybe users do not have an idea of what is actually segmentation and all that kind of things, and where do I find the keyboard and so on. But if users are not too shy, then usually that that hurdle is not too high. Of what we are currently not providing for the usual user is the training interface, but also this is very, very simple. So to train a model, as you can see here, I see here the document, and let's assume that someone has transcribed these 87 pages. Then I just would need to say, okay, I take this as training input and maybe one page as a as a testing page. And then I just would need to say that's my model and the language and some description, and that's it. And I just would need to press the button, and then it runs. Nowadays it runs for a typical model for 24 hours, let's say, but with the new GPU servers it will run just for probably 2 or 3 hours. So that will improve also very much. And then you get the model. And as you could see here, the models, yeah, we already have a lot of models. And here, a model where we have this typical overfitting, but e.g. here, a model which is very nicely. You can see that it was trained just on 8,000 words, a manuscript from 1596. Let's have a look how it looks like. And it's that kind of writing, but probably the writing is very um, distinct and regular, and then it learns fast. So as you can see here, that's already very good results for 8,000 words. We have other examples here. Something failed, so that also happens, that sometimes the parameters would then need to be changed. Another model, or here another Arabic model, which we trained. Here was the problem that some lines were incorrect transcribed, therefore it should be better than it is shown here. Or here, it started already with a base model, so we have the combination that we can also take a base model. And then it starts already with something like this, and it adapts to the specific. And as you can see here, 7% on the test pages is really good for that kind of writing. So from the Middle Ages, late Middle Ages, and yeah, and that's how it goes on and on. And of course, one of the next steps will be then to combine. As you see, we have a number of languages already, a lot in German, of course, English, Arabic, Finnish, and then to combine large models so that that we have robust models which support especially that kind of keyword spotting. Because for keyword spotting, it's more important to have a robust model which provides some output for every document in the collection, than to have very specific, very good output for some documents in the collection. Order of text regions. Yes, that's actually a big so with the new tool, it's actually not really necessary to set a reading order from the very beginning. Yeah. But as a matter of fact, if you have, so as you can see here, this was done with the new tool, and here it found something, maybe it is a writing, maybe not, I cannot say, probably it's not. It's probably from the page behind. But uh, when you have, let's assume that this is a real marginalia. Yeah, I think it's just a noise, but let's assume it's a real marginalia. You always have the problem of the reading order between marginalia and body text. So how to handle this? Often marginalia are a kind of headline. Often they are just comments. Um, yeah, so that's something which is, so we are already happy if it finds that this is a text block and that it is a different text block maybe to the running text. But then the next step is, of course, to have a kind of document understanding where I can say, okay, my marginalia are e.g. the conclusions and therefore for me a kind of headline for a document, or my marginalia are comments and have nothing to do directly with the document. So I would have them separate from the reading order, and that this becomes also something trainable. So there is a group working on that kind of document understanding, and I hope that we get some results in 2018 for that as well. Or that you have here, e.g., that's typical that you have here kind of closing expression and maybe a signature. Here's also a mistake in the line segmentation. A signature, and that you want to have this a signature because for that type of document it's regular, so you would like to be able to train that as well. So we are somehow aware of that, but currently the regions are on the same level. And yeah, the memorandum of understanding, we usually do a test project then with the people who sign this. So there's not a lot of commitment behind. It's just that usually we get transcriptions and image files, and then we do the matching either manually or with the automated tool, come up with a model, and then the providers or those who signed the MOU have a good idea of what they can expect and how it works on their documents and so on. That's the main thing. And if you are interested, just drop me an email, and I can send you a template and talk with you about your project. Then the second question. Yeah, to train Arabic models. Well, if you have transcriptions already available, then we just need the corresponding images. I mean, with the British Library, we already have a memorandum of understanding, so that would work fine. And you just send us what you have in any kind of format. If you have technical people in the team, then of course we prefer to get text files. But if you have them just somehow, we can work with them as well. So that's not a problem. And yeah, working with Transkribus, that's something you can start after this presentation. So everything is there. You just need to upload the document. We have several options to upload document. Easiest is just to upload a single document. We have now no limitation because there was a kind of Java heap space limitation. but nowadays we changed that, so you can upload also 1000 images of one document. It will work a while, of course, but then you can do it, or you use FTP for larger amounts. So that's already possible. And then just run the segmentation and either start transcribing by hand, and if there are transcriptions available, then get into contact with us.
Okay, I think that's probably all we've got time for today, but do get in touch with us afterwards if you've got any questions. Thank you very much, everyone, for attending, and thank you very much, Gunther, for the presentation and demonstration. Much, everyone, and
Thank you.
have a good day. Goodbye.
Thank you. Have a nice day.